Okay. Let's go ahead and get started. I know everybody's wanting to go. This presentation I'm doing is a case study. Uh, this is something that I figured out about 6 months ago, and I figured I'd share it. I'll say up front, I am not a cable modem DOCSIS expert, can't even pronounce it. I'm sure there's better ways to do this. If there is, somebody needs to tell me how to do it. But this is the way I did it, and it seems to work. What we had was, yeah, that's not working. Again, that's just showing how I've used a MikroTik router along with the cable infrastructure to get a cable modem system up and working. That's who I am, Vince Godnich, from a little town up in East Texas. Kind of said this, the issues we needed to overcome at this particular place was that we had I'll show you a picture of it in a minute. We had two different sets of housing. They were about a quarter mile apart. And the guy that was doing this did not have the money or wanted to put the money into a new infrastructure. He didn't want to lay fiber in. The only infrastructure we had there was an existing coax cable network that he was sending broadcast television over. And so we got to looking at it, and instead of rewiring everything, what we basically did was we added a low-cost CMTS, cable modem termination system, at the head end. He put some extra amplifiers in there for bidirectional stuff, and he was the cable guy. What I did was bring in a CCR routers, an edge router, and some other stuff, and we just basically, I configured the CCR up to replace the need for an additional server, additional provisioning software, because quite frankly, it just costs too much for this application. That software, plus not even counting the servers and stuff we would need, would be $5,000 or $6,000, what we found. So we decided to come up with a solution to this. This was one side of this housing unit. You can see they're all spread out. He had cable throughout the system, trunk lines. You can see it would be fairly expensive to run any type of fiber network through here. Have to have a switch at each of the buildings. To complicate it, we had this other unit that was about a quarter mile away. Same situation there. As you can see, they're separated. The place in the middle, this we didn't have access to, so there's no way we could run a cable from one to the other. So what I came up with was basically this. We had internet access. I had my CCR here. We plugged in a CMTS here. And these little things were capable of, there are several brands out there. They were capable of about 250 cable modems, DOCSIS 3.0, plenty fast speed, everything we wanted to do. I bridged across to that other unit with a couple MikroTik 60 gig radios, the dishes, they work great. Put another CMTS in over on this side, and away we went. For those of you that don't know, and again, I'm not the expert on this by any means, but had to figure out how cable modems worked. There's basically 4 steps to bringing a cable modem online. You turn them on and they start looking for frequencies over the coax. They lock into frequencies. They ask for a DHCP address. They ask for an IP address. Time of day, that's just something that was required. And they need a TFTP server to download a config file to. They do all this before they go through the process of rebooting. Most of the modern modems, I found out, are actually a combination of a cable modem and a client Wi-Fi radio. That's the ones we use, make it simple. Once the modem side comes online and it's operational and starts passing IP traffic, then the router side kicks in and it asks for the same information, basically IP address, gateway, mask, DNS server, as a normal router would ask for. So we got 2 different things going on here. What I did here is I separated the network, and I'm going to talk a lot about subnets because that's how I figured out, and this approach is to how to get the right configuration files and stuff like that to these different cable modems. So I broke the network in half. I've got a small Class C for my core. I've got a Class C for my modems and a Class C for my routers on each side. And you'll see why I did that in a minute. And again, that just kind of lays it out again. First thing you do, you just obviously configure your IP addresses. I've made 2 bridges on the CCR, one called Devon, one called Windsor. Those are names of the properties. Just put all my gateways on there. On the DHCP server config, what I've done is, again, to the modem, we need basically 3 things in the DHCP server. The normal stuff, you need a TFTP address and you need a boot file name. And then to the router, you just need the standard type information. And I think everybody knows how to set up the server. Thing to keep in mind, I think I'll mention it here in a minute, MikroTik only allows really 1 DHCP server per interface. So I kind of got by that, but the first thing we set up here were I set up DHCP options. Option 66, that's the address of the MikroTik, that's TFTP server. I just put my other time offset I put in, TFTP servers. I put in the syslog server just for my monitoring. I set up the individual options, and I just made a option set for each side. There's the option set. I just add the different THCP options to the option set. Makes it easier to configure in a minute. Then I came in and I manually created a network for each of my subnets. One network for the modems, 1 network for the routers on each side. Set those up. This is for the routers. It's pretty simple. That subnet 10.11.2 is going to be for all my routers on one side of it. That's pretty standard. Next, I set it up for the modems. The additional stuff you needed was down here. You need a boot file name, and obviously I put in the DHCP option sets, which point at that modem to the correct TFTP server. Next, I set up the TFTP servers themselves. Set up 2 of them, 1 for each side. Pretty simple to set up. Gave it the address range within the subnet of those modems. Gave it the file name it would upload. Next, I put the config files in the file folder, the MikroTik, and I'm going to go into more about the config files for what I know of them here in a minute. But you have to add those in there to make the TFTP server work. And then a quick word about config files. This was the hardest part for me. And like I said at the beginning, if somebody knows more about this than I do, please come see me. I'm willing to learn. But what I found out about this stuff is that it needs certain information, and it has to have a config file to boot up properly. Okay. I used these. It's a free online config file editor. You need upstream. You can put in stuff like, for the basic configuration, you need upstream flows, downstream flows, stuff like whether or not the customer can access the modem. That's a bad thing. You can put in community names, all that other kind of stuff in the config file itself. This is what that config editor looks like. Not going to go into a lot of details, but it's pretty simple. Once you kind of figure it out, you just come over here and you type in that's set for 55 megs of maximum downstream sustainable traffic. So you put those values in. You make it all work, and when you first print it out, you think you messed up because that's what it looks like. But that's what the config file turns it into, a binary file, which is what the modem has to see. So that's the file that you're actually going to upload to the MikroTik when you get finished with it. struggled with this a lot, and I kind of want to dwell on it. What and how many different config files you need for a particular setup. And there's different ways to do this in the way I found. I just use one config file for this. I set all my upload and download limits to be a little bit above what the maximum service level that we're selling. And then the actual bandwidth of the customer, what they're purchasing, I'm controlling via the MikroTik, via the IP address of the routers. Because remember, the routers are different than the modems. So I basically set the modems at a high level. I control my bandwidth and limit my bandwidth at the router level. I found it's a lot easier in this case to do it that way. You could control bandwidth at the modems themselves by using different config files with different subnets and all that other kind of stuff if you preferred to do it that way. I haven't tried this, but another option, you can configure a different config file to give priority to any VoIP customers you may have on your system. Just a quick note that I found out the hard way, if you change config files on a modem, that modem has to reboot. It's kind of obvious to a lot of people, but it took me a while to figure that out. Make the button work here. Well, come on now. There we go. There's a bunch of different, what I call deployment options if you're ever dealing with something like this. It can go from very simple to very complex. You can, if you were trying to do this in a hotel or student housing or something, where everybody's going to get the same service level, everybody's going to get the same bandwidth, you can just use dynamic pools in your DHCP. If you don't really care who gets what address, like I said, student housing, hotel rooms, whatever, if you didn't have any of those requirements to know who had what, just make a dynamic pool, dish them out. You can, in that case, you can really have just one subnet. You put all the normal information in. You put the config file information into that DHCP server. The modem will fetch the files, boot up. When the router goes out, he'll pull the same address out of the same subnet. He'll just disregard the need for that boot file or that TFTP server because it's not required. It will work like that if you got a very simple network. Another way to do it, which is the way I kind of did it, was I just used static lease assignments in my DHCP server. This is normally going to be used if you want different speeds and services on different customers. You'll have the ability to suspend service, cut them off, all that type of stuff. That's what I used in this case. What I've done here is, again, I've used different subnets on the system in order to get different config files to the modems. Okay, it's one approach. The reason I'm using different subnets, and I tried this way and it works. If you're going to deliver a different config file to a different class of customer at the modem, it works fine. Again, there may be an easier way to do it, and again, the reason you need to go do this, what I found is that you control the config file by the file that's uploaded. And again, you can only have one DHCP server per interface. So the config files are specified in the DHCP network section as well as the TFTP server that they pull. Again, this is all based on the fact that we do static lease writing in the DHCP server. Okay. I found too that if you separate your different classes of service and stuff like that by subnets, it's a lot easier to control things. An example would be your cable modems really don't need to access the internet. There should be no reason why they have to. So keep them on the same subnet, just block that whole subnet from, just don't put it in your natting tables or your masquerade tables and they can't get to the internet. You can also restrict your modem access to only what's needed, obviously, with firewall rules. In this case, I can map different subnets to different public IPs kind of separate things out. So it makes it a lot easier to do it that way by subnet. Again, kind of starting to put it all together. Here's the networks. That's a specific subnet. In this case, for a modem, it's got the config file down here. It's got the DHCP option set. Under the TFTP server, pretty much same setup. I drop the config file I want. That's going to correspond with the modems that I put on that subnet. And again, kind of backtracking a little bit, if everybody has the same modem, service level, everything, just use a DHCP pool and just go for it and let it do it. Option sets, again, would remain the same for both routers and modems. The routers would just ignore what they don't need. And it's the simplest, easiest way to do it. Here I'm just adding my, under the dynamic section, obviously you'd have to put a DHC pool in there and specify the addresses. Again, I've done static lease assignments, and I found I know probably at least 2 ways I know work and 3 that probably will. You can just manually enter, and again, DHCP, you do the static lease by MAC address of the device you want to give an IP address out to. So you can just manually add them in, real simple. You turn off the pools, you make the DHCP server static only, and you just write them in. That's one way to do it. If you had 20 or 30 guys, that would be fine. Another way, which is, again, the way that I did it, we used a third-party billing platform that wrote static leases and did a bunch of other neat stuff. I won't say who it is, but I think everybody can guess. There's 4 or 5 of them out there that you can use. Or you could use a radio server, either a remote radio server, local radio server, or I've actually got User Manager to work with this. It's a radio server after all. Again, writing the lease manually, you just need to go into the server, into the correct server, set it to static only. Hang on. Hello. Here we go. Give it the IP address you want out of the subnet you want. Get the MAC address in there. In the cable modem side, I found this is called the HF something or other. You make sure it's the MAC address of the radio side or the cable side of the modem. Drop your option sets in there and you just write each one manually. Obviously you comment it out. Let people know who's on who's what. The router, you need to do the same way. Again, the router is where you're going to control your internet bandwidth and all your different speeds. You can do it that way. And that's pretty much simple. After you do that, I may cover it in a minute, you can go in there and you can write mangle rules, you can do your queues, you can do all that stuff based on the subnets or the IP addresses of the router side of these things. Works good. The other way, you can use a third-party type thing. You just put the MAC addresses of both the modem and the router. You put them into the third-party billing or provisioning software. And again, that's fairly inexpensive. You can assign services to those individual customers. In the case file I've only got 2 subnets, one for each side for the routers. We can control the bandwidth, the service levels, all that other type of stuff by individual IP address through address list and stuff like that the third-party stuff will automatically write to the MikroTik. And again, doing this method, you go out to the portal, you put in a new customer, put their MAC address in, assign them an IP address, and the third-party billing will automatically write to the MikroTik via the API interface. The only thing you really have to do is enter the appropriate API information, make sure you enable it under services, give it a username and password, which should always be separate than what your username and password is. And the end result is that it writes leases for you. You see I have 1, 2, 3, I've got 4 different subnets being written in here. Modems, routers for one side, modems and routers for the other side. Once that is in there, this particular software will automatically go in and upgrade some access lists. You can also create these manually if you want. We've got delinquent customers. That has to do with redirect, cut them off if they don't pay. Down here I've got 25 by 10, 40 by 20, 50 by, these are all the different speed classes and services. And as you can see, some of these same classes can be in the same subnet, no problem, because I'm configuring, we're controlling bandwidth with the IP address, in this case, of the router side of it. If you didn't want to go with this, you could, again, separate out your different services by subnet, if you chose to, and then just do your queuing on the MikroTik by subnet. It's a lot easier that way if you had to do it manually. Or, and I'll cover in a minute, you can actually push a different config file to each modem for each different class of service. So there's lots of ways to do this. Just kind of give you the overall of what could happen. Here's an example of some angle rules and some the queue trees and stuff that software wrote. Again, in this case, it's automatic. We're going to end up with about 400 customers out at that site, so we decided to go with the automatic solution instead of having to hand input each one. If you got a smaller site, there's no reason why you can't do this type of stuff on your own, especially for a hotel where everybody's going to get the same bandwidth, all that type of stuff. This could be simplified down real easy. Do your queuing, doing all that stuff just by the subnet of the routers, and everybody gets the same service and everybody's happy. This particular thing, we can actually redirect customers when they don't pay. Again, that's an option of the billing software that we have. They get redirected to a customer portal which tells them to pay or they don't get internet access. Same basic thing here. We're just redirecting. We can also put people in an inactive or suspended state. Again, just put them in here, write them to a different address list, handle that address list by individual IP, however you want to handle it. If they're suspended, you don't want to delete the account per se, just tell them they can't get to the internet until they call you back up and catch up on their bill or whatever the case may be. I have played around with User Manager. It does work with this. User Manager is really just a radius server. So you can write your static DHCP leases. You still have to have the MAC address. You just use the MAC address as the username, and you can create profiles and limitations within User Manager. Again, that's all built into most MikroTik devices. Just put the username, put the MAC address of the router here, give it the IP address you want, bind it, and you can go in and set a profile up if you want, which you probably have to do. You can get your rate limits and stuff all right here within User Manager based on, again, different classes of service that you put. Limitations go to profiles, profiles go back to users. You can have different users with different profiles and different band rates. Again, this would probably be the least expensive way to do it. You don't have to pay for that third-party billing. Again, if your system's not that big that you'll get overwhelmed. I did play around with using hotspot in this. There wasn't real need for it, so I didn't go into a lot of depth, but there's no reason why you can't integrate hotspot in with all of this. If you're familiar with hotspot, want to use that, there's no reason why you can't do that. And to kind of summarize up real quick, the only real difference in this system and a wireless system or a fiber-based or Ethernet-based system is obviously the layer 1 stuff, having to deal with cable instead of fiber or wireless signals. You have to have a CMTS, which is an expense, but again, there's fairly inexpensive CMTSs out there. You don't have to spend $20,000 or $30,000 to get 200 customers online, or buy some old junk that won't work. So the physical layer is obviously different, but from then on out, the only real difference that I found between this and the others is the need to push that config file to the modem on a layer 2 and layer 3 basis. And again, I came up with this just because we didn't need all this other packaged provisioning server stuff, provisioning software in order to go along with this, because my customer just wanted the most inexpensive solution he could to service service a couple hundred people. That's really what I have. If there's any questions, I'll entertain them. And like I said, I'm not the expert here, so if anybody has a better way to do this, please see me after this. Any comments? Yes, sir.
The only thing, looking at this, if you did use hotspot, the neat thing about hotspot is when you plug in a device, the MAC addresses already show up in your DHCP server and in your hotspot, so it becomes real easy. And then on your DHCP server, you right-click on a device, say make it static, and you're done. I mean, and it works real well.
Yeah, I'm not saying that it'll work. We just didn't want to use this in this particular system. And again, I didn't go in detail on that. As long as we can change that DHCP server to push the right config file, no problem at all.
And in the redirect server and all that stuff is already built into hotspot also, so you don't even have to monkey with that.
Would you be willing to share your modem config file and router config file by chance?
I don't know if you want it. Get with me afterwards. It's not that. The one I'm using here is very, very simple. I have modified it a little bit, and I'll be happy to share it to you. Now I have SNMP access to this, but for sure get with me and I'll share it with you, no problem.
Thank you. Any more questions? Thank you, Vince.